Okay, well, welcome back, everybody. And I'd like to say thank you to Karma for chairing a fantastic Driving Innovation Forum. I think it was very informative and inspiring to us all. So we're now going to start the Data and Leakage Forum. Over the past 20 years of this conference, the place of data in the work of leakage managers and their teams has moved away from what was the focus on telemetry data to complex data sets from many different sources. The fact remains that data is only as good as the information that goes in, and critically, analysis that is drawn from it to inform strategic and practical approaches. Today we have two case studies, or we have case studies from two water companies, from Yorkshire Water and from how data science teams work and how teams are having to adapt and change and what impact that is having now as well as for the future. I'd like to start off by welcoming Chris Smith and Carol White, both data science managers at Yorkshire Water, who are now going to talk about the application of data science and how it is contributing to Yorkshire Water's leakage ambitions. So, over to you.
Morning all, thank you all for joining us. So yeah, it's Carol White here and Chris Smith from Yorkshire Water, two data science managers. So we're going to talk about the data science journey at Yorkshire Water, where we've come from, where we're heading to, and then also go into some case studies around leakage specifically. So next slide, please, Chris. And another, I've got two intros. Okay, so data science at Yorkshire Water. There are three main areas of data science activity that we do here. So we've evolved from a largely asset analytics team over the last 2 or 3 years to circa 20 data scientists now and their managers. And we support the business across clean water, customer experience, wastewater, HR and finance. So the three main types of activity we do are shown here. So the first is on the left, upskilling and BAU work. So supporting our colleagues across the business as part of a knowledge transfer. That might be things from Excel training, VBA support, partnership working. So if bits of the business have got external consultants in, we want to support on the data science there. We've got mentoring in place and then knowledge transfer for bringing. In the middle there, you can see some examples of our tactical work. So these would be the standalone projects, quite reactive to business need at that point. It might be a dashboard, for example, showing where the volume of our customer calls are coming from and what they're for. It might be a dashboard showing where the night use is across our region. Or as you can see there, some of the maps that we produce as part of our GIS work. And to the right, which is where we've been moving to over the last couple of years, is our strategic work stream. So that's when we can fully productionize our models, make them automated, deploy them into the business so the business can self-serve. Because that middle one there, the tactical, tends to be harder to do. We do it once and then to repeat it is a lot of work. So we're moving to the right there. Next slide, Chris. So how are we going to get there? So we're using lots of techniques like machine learning and AI for predictive modeling. But as Pauline, I think, said, the data is only as good as the data you're putting in. So our data science needs that data kind of to be cleaned and readily accessible. So what we're doing at the minute is building a data-centric organization. And the main thing we have to get right first is that strategic data platform. And that's going to be pulling in, well, it already is, data from within the company. So we've got customer data, SAP data, rainfall data, but also external data. So thinking broader to open data, and that might be council traffic data, various customer demographic data that's freely available, open source, and we're pulling that into a curated data set. This then enables us to do these business enabling use cases. So these might be efficiency initiatives or more strategic initiatives, and we'll be talking through some examples. But what underpins all of this is we need to get the governance right, the data quality, and form this centre of excellence so that the business truly sees data science and the data-centric hub as critical to delivering these use cases. Next slide, Chris. So how are we getting there? So, as I said, it's been a journey over the last couple of years, but essentially we've been trying to build our key guiding principles. So defining ourselves as this data science hub. So what are those? We need all of the insight that we're delivering to the business to be actionable. It's one thing saying what's happened, but actually what can we do with that information? We're trying to enable strategic change, ensure that our work is sustainable and accessible to all. So making sure that we're delivering pieces of work the business can self-serve to, rather than needing us for every step of the way. And ultimately ensuring it's customer focused. And customers might be internal or external. The way in which we're doing this is by implementing agile delivery. So you can see there in the green and red bar graphs, the agile delivery method is to deliver incrementally through time, which minimizes the risk as you deliver a project. And this is a move away from the more standard practice you see in most companies of waterfall delivery. So planning it all in advance and then boom, delivering in one big suite at the end of a project. As part of agile delivery, we have to reprioritize our workload frequently. Business demands, as we all know, ebb and flow. We have more reactive work coming in. So ultimately, we need to make sure we work on the right thing at the right time. And to do this, we then deliver MVPs, so minimal viable products. If a dashboard is required to deliver a type of performance, the minimum dashboard is what you need to get going to have that actionable insight. It's not the all singing, all dancing bells and whistles that ultimately might look better, but doesn't necessarily add value. And as part of this, we need to be adaptive. So we're making sure the team that we've got are all trained in agile delivery and are able to adapt to the changing demands of the wider business. So as I said earlier, we don't just work on the clean water side. So on the right there, you can see a case study of something we've recently delivered through this approach. So we've just built a natural language processing model, so that's machine learning, to capture how our customers are feeling from their written feedback. So now it's fully automated into our strategic data platform. No longer does somebody need to download, say, 100 customer feedback texts, run it through the model and spit out how those 100 customers were feeling at that time. The customer feedback is flowing straight into the strategic data program and spitting out into a Powered BI dashboard, which can be updated daily or more frequently if required to show how our customers are feeling. We can break that down and then into different areas of the business. So how are customers feeling on a particular journey? So for example, if they have had a leakage journey or an ISF, internal sewer flooding journey, how has their emotion changed during that time? And it moves further from going to scores of 1 to 5, the 1 being that wasn't great, please do better, and 5 of that was excellent. We've been able to employ machine learning to understand from the words our customers are using, not just if they're happy or sad, but if they're frustrated, disappointed, there's a lack of trust perhaps, or maybe they're surprised and excited by something, which is, I'm sure, hard to imagine from a leakage journey, but there will be journeys across the wider water networks journey that will have elements of those things in there. So before we move on to the case studies around leakage, the key considerations in setting up a data-centric organisation are listed there. So the technical enablers. Do you have the technology in place? Do you have the right people in place to get your data into a data lake? That's one of the big things Yorkshire Water's worked to overcome over the last couple of years. How will you deliver to multiple streams? So your data science team are likely to be delivering to more than just leakage. So how should they be set up to deliver across the business? How do you prioritize this workload coming from competing areas of the business? So the key bit there is for all business cases to have benefit attached to them. What will they deliver tangibly? Is it a reduction in contacts, a reduction in leakage, or reduction in sewer flooding events, for example? And ultimately, it's getting that data ownership and governance from the business as a whole. Your customer teams need to be willing for you to work on live customer data and the risks that come with that. So I've just seen Chris's camera's gone off, so I hope he's still there to pick up the next bit, which will be around the specific leakage examples.
Yes, I'm still here. Hopefully you can see me. So let me just get this going. Yeah, so thanks, Carol. So yeah, my name's Chris Smith. I'm a data science manager at Yorkshire Water, so the same role as Carol. My team have historically focused on the clean water side of our business, so everything from water production through to leakage and distribution. And so what I'm going to talk through today, a couple of examples of pieces of work that we've done in collaboration with the leakage team in the past. So a lot of these pieces of work will more readily fit into that sort of tactical arena. So bits that we're doing with the team to address sort of immediate issues, but then start to have an eye on that more strategic delivery. How do we sort of get to those more sustainable benefits? So As I run through these examples, I'm going to be focusing less on the methodology, the specific methodology we used, or the specific results we saw at Yorkshire Water, and talk more generally about the value of doing this type of work, and also the key considerations that we need to be factoring in once we look at it. So hopefully you'll leave this session when you get back to the virtual office on Wednesday. You can start firing off emails to your internal data science team, internal analysis team, start pestering them for support in this type of arena, unless you work for Yorkshire Water, of course, in which case you can ask politely. So yeah, the first one, really common piece of analysis that we're asked to do is just around benefit assessment. So quantifying the benefit we realize from existing approaches, new approaches, bits of innovation. How is that impacting our leakage performance? How is that improving our efficiency? How is that improving our ability to meet our stretching targets? So really common, like I say, we do similar analysis in all areas of operational performance. And the reason we do it is quite obvious. Obviously, it's important to understand how effective, how valuable our leakage management activity is. How does it compare across different approaches, different techniques? When you're bringing in new technology, how does that impact that performance as well? Central to sort of the current AMP and the challenge, how does that performance deteriorate, or the benefit diminish as leakage is driven down? So it's important that we continue to monitor where our performance is now, and then as we progress to lower and lower levels of leakage, how is that changing? And is it changing consistently across the region, or are we seeing differences start to appear? So the map you can see in the top left-hand corner there, that's a map of Yorkshire based on normalised leakage performance. And the eye can quite clearly see there's a big difference between how our leakage performs in the more urban areas, so in the south and the west, places like Leeds, Sheffield, Huddersfield, sort of big operational challenges there. And leakage tends to perform significantly differently, in most cases better, in the more rural, sort of northern and eastern parts of Yorkshire. So it's important that we acknowledge that we don't have a common leakage challenge across our region. We need to understand how the different processes perform in different areas linked to different challenges. This type of work is also really critical in establishing the cost benefit of new proposed solutions. So new investment in telemetry, new capital solutions, be it pressure optimization or renewal schemes. Does the benefit we see, either as part of a trial or a proof of concept, or the benefit that we can project, does that justify the investment? Does it justify in AMP? Do we have to cost that over several AMPs to get that benefit? Obviously, central to answering those questions is understanding the value of that solution. Once you understand the value, particularly if you're looking at a trial or a proof of concept, you need to start establishing it. That's what I've observed in that area. What's the full potential for the region? Does that can we extrapolate that linearly, or do we expect that to sort of be exponential in the sense that we expect sort of that sort of 80-20 rule, where we see the majority of the benefit in sort of the a limited deployment, and then that diminishing quite quickly? So again, these are the types of questions that we've been working to support. And then finally, obviously, once you understand how effective your current process is, you can start identifying where those differences are and start thinking, right, how do I improve? How do I improve the benefit realized through existing processes? Or how do we take what was observed in a trial and realize additional benefits as well? So really fundamental questions that we've been supporting the team in answering. The key bits to consider when you're approaching analysis of this type: firstly and fundamentally, leakage is a very transient thing. It changes daily. It's if you would have looked at the leakage position a couple of months ago versus where we are now with the weather we've had, they're completely different. And it seems obvious, but it's really important to consider when you're doing a benefit assessment, where are you sort of defining that start and end period? Because the leakage performance you're looking at, particularly over several months, could have changed significantly. So one way around that is to use a control area. So you've got a trial area where you're trying a new technique, trying a new technology. Can you find a control area that's relying on more traditional approaches, that's comparable in terms of where it is geographically, how it's built up in terms of mains material, pressure, etc. And you can observe the difference in the way leakage performs in those two areas and understand what is this additional approach giving me in that trial area that I'm not observing in the control area. So as an example of that, if you look in the top right, what you can see is performance that we observed as part of our acoustic logging trial that we implemented a couple of years ago. So before we did a large-scale deployment, obviously we did a more focused trial to understand the benefit of that technology. The blue line is the observed leakage performance in that trial area. And if you look at that, you can see that leakage is going down slightly, but it's relatively flat for the majority of the year, which you could argue that hasn't realized much benefit. But when we bring in the predicted performance, so what you can see in that dotted black line, that's based on what was observed in the control area, what was observed historically in those DMAs, which tended to be sort of highly reactive, high rate natural rate of rise DMAs. You can actually see that there was quite a significant change in performance as a result of that technology and as a result of that trial. So that brings us to the second point, which is just about understanding that trial versus business as usual. So using those control areas to quantify benefit, understanding what the technology is giving you beyond what you would have observed anyway. It's also important to consider, does that trial represent what business as usual is going to look like following full deployment? So often with a trial, you're looking at a small area, often with a dedicated team. It's new, it's shiny, they're wanting to react to all the potential insights that are coming from that technology or that approach. So it's just that word of caution to say, is it perfectly translatable to this is what was observed during that trial to full deployment? And then the final point that also links to that is just about understanding the attributes that determine benefit. So if you're looking at that trial or proof of concept approach, does that area reflect the rest of your region? And does the benefit you see in that area, is that determined by the makeup of the area? So in that acoustic logging example, picked areas of high failure, high proportion of cast iron mains. If we take the benefit observed there and just multiplied it by the whole region, that probably wouldn't be legitimate, because obviously you're seeing a greater benefit in more reactive areas, and obviously the benefit observed changes based on the material type. So again, just taking the effort to understand the factors that may influence the benefit that you see is important when you're scaling that benefit up. So next one, so that was about hindsight, so observing performance as part of trials. This is more about foresight, so getting into understanding how leakage performance is likely to pan out over the course of a year, over the course of an AMP, and obviously using statistical models to try and forecast performance. So leakage is very seasonal, leakage is very volatile, it's very influenced by external factors. That makes it perfectly suited to forecasting approaches. That seasonality, that volatility, you can pick that up, you can quantify it, and you can reflect it in forecasts. Obviously it's not an exact science, but it's definitely an area that we've been exploring extensively, and I'm sure it is been explored across the industry as well. So hopefully the benefits of forecasting are fairly self-explanatory. Obviously they help you with your business planning, understanding what level of investment, what level of resource, what the leakage challenge looks like, both in year and across the AMP. It's important in determining operational targets. So obviously leakage is very volatile. A lot of the risk exists in the winter. I'm sure many of us are feeling that now. And it's about understanding, based on the range of results that I can potentially expect to see in my winter performance, what level of headroom should I be driving for when things are a little bit quieter on the leakage front? So making sure that the operational targets are responsive to that range of risks that exists at the back end of the year. And linked to that, obviously, as we progress through into the winter period and summer as well, to a lesser extent, it's about monitoring that risk as it develops, and obviously understanding how that could potentially impact that in-year and that 3-year rolling performance as well. So in terms of delivering forecasting, it's important to obviously understand the relationship between those external factors and leakage and try to quantify them. So temperature, rainfall, soil moisture deficit, customer behavior, these are all factors that matter and can be observed to matter to leakage performance. So lots of work in understanding the relationships there. There's a couple of examples. Say in the top right, you can see that's the correlation between the minimum temperature in winter and the number of reactive mains failures. So you can see that relationship where colder temperature equals greater mains failure. No surprises there. We've replicated similar analysis looking at soil moisture deficit in the summer period, and that's really solidified our understanding of the different factors that influence our performance. So linked to what I was talking about before in terms of benefit, when you're forecasting, particularly over an AMP where you need to see leakage improve significantly, it's important that you reflect that benefit in your forecast. So how many resources are you going to be employing? What benefits you're expecting to see from capital activity? What benefits you're expecting to see from innovation? Include that in the forecast. And obviously, what's important to recognize there is also volatility in the benefit you realize. So make sure that benefit is captured in the forecast. And that really sort of comes on to that last point there, embracing that uncertainty. We can't predict the weather. We can't predict, what is it still going to be snowing in a week's time? Is it still going to be snowing in a couple of weeks' time, in a month's time? We don't know these things, but if you create forecasts that reflect the range of outcomes that you could expect to see, and a good approach for that is Monte Carlo analysis, where you basically simulate multiple future scenarios and then you understand the distribution of those scenarios following that process. Really crucial in leakage and across the range of our operations as well. So a final one for me, and this is where we get into more of the strategic work that Carol alluded to. This is really central to what the strategic data platform can enable us to do. And it's already come up a couple of times in the various discussions. The idea of a situational awareness digital twin, getting those insights, getting those analytically derived decisions, getting them embedded in the day-to-day operation of the business. Sounds easy. It's very difficult. It takes a lot of investment in IT architecture and infrastructure. It takes a lot of investment in sort of analysis and understanding benefits and how to sort of play that out in real time. But this is where the sort of the biggest gains are likely to be found in terms of sort of realizing improvement in efficiency. So essentially where analytics comes in, most obviously it's about assisting in that decision-making process. So one of the things that we've been looking at over the last couple of years is using analytically derived insights to drive or determine where we send our leakage resource. So obviously we've got a finite level of resource, quite a vast operational area. Where's the most beneficial areas to send them? Where's the most beneficial areas to prioritize in terms of leakage activity? And it's not necessarily just the ones with the most leakage. It's about understanding the nature of that leakage. So how do we typically perform in an area that is gradually rising versus one which is broken out? How have we performed in certain areas which are more stubborn? So we've invested a lot of effort, a lot of activity in that area, and yet we're not quite seeing the results. What's the factors that determine those areas, and how do we get them reflected? So when they come up for prioritization, we're not just repeating the same activity in the past that hasn't yielded the benefit we'd expect. So identifying those problem areas and sort of promoting them for a different route of escalation. Obviously, you can also start to bring in performance indicators. So understanding, are we targeting the right areas? How successful have we been in realizing the benefit that we'd expect to see? How is that differing across different regions, and really equipping the leakage management teams and operations with that insight into their own performance to drive improvements. Key considerations when you're trying to deliver this, obviously, Carol already alluded to it. It would be very difficult to deliver this type of activity with that sort of traditional waterfall approach. That approach whereby you have to sort of really define what it is I'm going to deliver, what's going to add value, what do the leakage teams need to see. I can't see how that can be delivered effectively through waterfall. That agile approach of delivering little and often, give the team something, that minimum viable product to play with, understand if it's adding value. If it isn't, look to build upon it, trying to change things, and obviously sort of build a solution with them over time that evolves. Once often with these things, once a dashboard gets to a point where it stops evolving and stops sort of you stop hearing from the Leakage team about what they want to see, what it needs to give them, that's often when it's sort of tailing into sort of well, it's dying basically. So it's good to have those constant conversations, trying to evolve with the process. Just finally, just conscious of time, trying to incorporate those benefits. So understanding where we see benefit versus how a DMA looks like in the moment, and sort of reflecting that. Integrated view of the network, so bringing in all these new sources of information, new bits of telemetry, bits from customers, bits from social media, bringing them all together in a view that equips people to make the best decisions at that time. And obviously the importance of having that data available and accurate, but also the speed of that data. This is the challenge that we've had without the strategic data platform, is producing this information in a way that's quick enough that it's meaningful for the Leakage team, and we're not sort of lagging behind them. We're giving them what they need in the moment, and they can act upon that immediately. So that's it from me. I hope you found that useful. And yeah, if you've got any questions, obviously there's a Q&A after this. So we can.
Okay, I would say thank you, Chris and Carol. I'm keeping an eye on time. I see we've had one question come in, but I'm going to hold that till we finish with Chris and Willow. So I'm going to go straight introduce you to Chris Rees and Dr. Willow Smallbone, who work as Leakage Manager and Data Analytics Manager, respectively, at Welsh Water. So their presentation will explore the way in which data is managed and how some of the data science techniques are deployed to help inform the Welsh Water Leakage team. Over to you, Chris and Willow, please.
Thank you.
Great, thanks, Pauline. So yeah, if we can have the next slide. Okay, perfect, thank you. And so yeah, hi, I'm Willow. I'm Data Analytics Manager. So I manage the data science team. So I just wanted to start by giving you a bit of an overview of the data team here at Welsh Water. And so we like Yorkshire Water support the entire business. So everyone from the waste side of the business, clean, retail, as well as all the support services, so HR and finance and the like. So the data team is made up of five sub teams that you can see on the screen here. So starting with data governance, and this team really supports the business in terms of improving data quality. So it's utilising data stewards and data owners in order to try and embed data quality within like everyday work that the business is doing. So rather than the data governance team driving improvements in data quality themselves as quite a small team, it's about empowering the business themselves to improve on that data quality and try and embed more of a data culture within the organisation. And so they measure the success of their work through the data maturity and through various data maturity, very much working in collaboration with business areas. Secondly, then the data engineering teams. This is a team that's pivotal in really all of the work that the data science team do. So it's kind of the underpinning of us being able to access a lot of the data. So it's around developing and populating our enterprise data platform, so our cloud warehouse. But they also manage kind of our interim solutions on premise with our SQL servers. The business intelligence team then are leading our centre of excellence in terms of ensuring that we have a centralised approach to business intelligence as an organisation. So as every business, I think there's a lot of reports out there that kind of have a different use different sources of data and that maybe have different levels of reliability. So the Centre of Excellence is there really to try and encourage kind of the same look and feel for reports that we're pulling together, but also encourage the use of kind of a centralised approach to data and putting that data governance in place and trying to get to a one version of the truth kind of approach for reporting. And finally, then the data migration team kind of is there to support the business to move to new systems. So as we move it, just as an example, moving to a new HR system at the moment. And the one that I've missed there is my team, the data science team. So we're kind of a team of colleagues that have got a broad range of skills, and really our focus is on predictive forecasting kind of types of analytics, as well as artificial intelligence, simulation, optimization, and application development. So we've got a really broad range of kind of skills with no two people having the same skill set, but as a whole kind of being able to build that up. And really the idea behind our team is to take a business problem, use data and analytics to be able to provide better insight to the business to help make better data-led decisions. So it's not for us to give an answer, it's for us to be able to provide that information back to the business to enable better decisions to be made. So all of the work that we do are aligned to strategies. So in this instance, we align to the leakage strategy, and we're ensuring that we're delivering to kind of aligning our projects with measures of success. And obviously the kind of the variability of the projects we deliver means that every project kind of needs its own bespoke solution. So if we can move on to the next slide. Just wanted to provide a bit of background really as to where the data team had kind of the journey that it's been on. So it started in 2014 just with one individual kind of managing kind of starting, I guess, data science within Welsh Water. And through just a handful of years, we've kind of built to be a team of 22 across the whole data team, with about half of that being the data science team. And as Yorkshire Water previously mentioned, the importance of the data quality really underpins it all. So it's although a really small team, it's obviously a pivotal team to ensure that the work that we're doing is of a high standard. And on to the next one. So kind of, I just wanted to talk you through kind of our project life cycle in a little bit more detail. So the kind of the way that we work is very much in aligns with kind of how Yorkshire described it, and really that's around kind of the pre-work. So really understanding what that business problem is, scoping that project out, really talking with stakeholders, understanding the business challenge, getting to the root cause of that challenge. Sometimes the challenge that comes to us isn't always kind of the root cause, and sometimes when you start to understand a bit more, you really understand kind of how we can better support. And during that process, obviously understand what benefits the project could bring, and going through all the data protection and kind of information security kind of requirements to ensure that everything we're doing aligns with kind of legally what we're allowed to do. Moving on then into the kind of 4-week sprints where we work with business owners to develop minimum viable products of models and user interfaces, gaining feedback as regularly as we possibly can, before then getting to a point where everybody's in agreement that it's kind of fulfilling what we need. And then it kind of goes through the final processes. That final model is built and the user interface is signed off, and we kind of formulate as a collaborative kind of a deployment plan and understand how we're going to embed. And it's already been alluded to that, you know, that's often when things fall over. We have very similar challenges, and it's all about kind of getting the business involved, kind of them taking ownership of the product rather than us. You know, we can't really instill change within processes that we don't fully know or fully understand, and you know, we have no real, you know, kind of reason to. But it's really important that in this instance the leakage team kind of take that responsibility and run with it and change process that needs to ensure that we can embed this type of work. And finally, and most importantly, really, it's that monitoring and running of the models. So, you know, a model may have started out at 95% accuracy, but through time you start to get data changes, and, you know, COVID being a prime example of that, where it's completely skewed every data set I think that we all hold. But it's about monitoring that data to see how it's changed and see what impact that has on the model, and picking that model up then to rerun if necessary. Next slide.
Thank you. Can everybody hear me okay?
Yep.
Yeah, great. So thanks, Willow. So I'm Chris Rees, I'm the Leakage Strategy Manager at Do Cymru. I'm going to give a brief introduction to a data project that, through collaboration between the Leakage team and the data science team, we have successfully implemented very recently. So I'll let Willow explain in slightly more detail on the coming slides the tools and techniques used in the delivery of the project. But I just thought I'd give a bit of an overview of well, this session and where this idea came from. So the idea of this session stemmed from a discussion in the Water UK Leakage Managers Network meeting probably a year ago, and I think it was actually a week before the lockdown started. So I think it was the last time I saw colleagues in a year. So in the world of leakage, we've been practicing data science techniques for many years, and we have complex software systems which have been developed over time. More recently, the quantity of data that we generate is probably growing exponentially from our ever-increasing data sources, installation of network sensors, and that's kind of coincided with the emergence of data science teams within water companies, and also the specialism within the supply chain. So I think this puts us as leakage practitioners in an ideal position to harness the benefits that data science can bring. So I'm sure this photo and the photos on the screen there bear some resemblance to scenes our leakage teams are facing across the east of the UK at least, and it's actually just started snowing here too. This is actually a photograph of a mountain rescue team from North Wales, and a volunteer member of that team, Craig Jowett, one of my colleagues in Welsh Water, working as an analyst in the leakage team when he undertook a rescue over one weekend. You can see in the photograph the planning activity which the team undertook using probability search theory prior to undertaking the rescue, where factors such as age, experience, last known location, and weather are taken into consideration in order to highlight the search route and localization of the missing person. Thankfully, that was a successful rescue, and it got Craig thinking about how similar techniques could be used to help localize a leak. I guess they had an advantage. The casualties are above ground, our pipes are below ground, but we do have a wealth of data and network sensors and an underground network. So Craig submitted an idea, Project Nemo, with the intention to help us localize leaks. So although our coverage of network sensors is increasing, and we'll hear over the course of today and tomorrow about some of the fantastic equipment which is now available to us, we won't get the coverage for some time. So therefore we saw some real benefit in developing this project to help us target reactive leakage breakout. We often use our more experienced leakage technicians who've built up knowledge of areas over many years to respond to these events, even though the leaks are often the easiest to find, really. This is due to the large impact these leaks can have to reported leakage, and also, potentially customer impacting as well. So Project Nemo aims to help equip any technician with a local knowledge to help locate these leaks. That gives us the opportunity to use the most efficient resource then for each instance. As well as this efficiency, it also provides us with the ability to respond to leakage outbreaks events, which most of us have probably seen at the start of January, through the use of resource and teams wider than just the leakage team. In our instance, we've used meter reader technicians quite recently, utilising this technique. So I'll just hand you back to Willow to explain in a bit more detail.
Hi, yeah, could we have the next slide, please? So Chris just gave a nice summary of kind of how Project Nemo came about. So really the current situation was kind of, where are our leaks, and like how can we find them quicker, and obviously then be able to resolve those leaks quicker. And with the kind of the proposed solution to be able to kind of identify where a leak is most likely to occur, and then provide an optimized route for us to be able to locate those within a DMA. So next slide, please. So there's a whole host of benefits that kind of can be associated with this particular project. Obviously, reduced leakage being kind of a key one, but it's also around kind of the improved productivity and the kind of the feeling that the workforce get from increasing their productivity. Obviously, everybody wants to go out and find one, maybe several leaks every day. And unfortunately, that's not always the case. So the more that we can do to make the team feel more empowered and have all the data that they need to be able to do their job better, the better, and the more engaged you get to make those people. Obviously, in doing that, you're reducing environmental impact through reduced leakage, but also providing a safer working environment by being able to kind of better plan the route that needs to be taken, and also reduce kind of the locations that an individual may need to go in order for them to be able to find the leak. But really the kind of the pivotal bit of all of this is using that data as best we can, data to enable us to be able to provide better understanding of where the leaks may be, but also to drive investment. So if we know that there's particularly high risk pipes that are almost always predicted to leak when we have a leak in a DMA, well, why don't we invest in those? Why don't we make a kind of more proactive decision to in order to kind of reduce that risk? So if you can go into the next slide, please. And this project was kind of broken up into kind of 5 phases. The first phase being a proof of concept phase in collaboration with Cardiff University. So every year we support several students with their MSc dissertations through Cardiff University and University of South Wales. And this was a project that we put forward to Cardiff University in order to support a student with supporting them in collaboration with the Leakage team to deliver a model that would identify a leak location. So we provided them with data, we provided them with some business knowledge, we provided them with kind of access to the stakeholders to ask questions so they could get a really good understanding. And what this proof of concept showed was that it is possible to use statistics in order to kind of identify where a leak is likely to occur. And this meant that we kind of felt that we could put more resource internally into this project in terms of kind of taking it kind of to a fully fledged project. So high level, this project was broken down into four kind of, I guess, sections to a project. And I'll go into a little bit more detail. But first, we started off by looking at DMA clustering, so understanding similar characteristics for each DMA, predicting the location of a leak, followed by creating a route optimization, and then obviously the user interface. So if we could just go on to the next slide, that would be great. So the first element of this was DMA clustering. So this was the starting point for this project, and really the reason behind this was to understand DMAs and how they were similar based on leakage and pipe characteristics. So we pulled together a whole host of different data sets to understand kind of the similarities between DMAs. And the reason for doing this was rather than building a separate model for every DMA, which would be hugely intensive in terms of compute, we wanted to build a model for each of the groups. So obviously this would massively reduce the number of models that we needed to run, the costs associated with that, but also the time and the compute required in order to do this. So we used clustering algorithms to understand kind of how our DMAs clustered based on, as I say, leakage and pipe characteristics. On to the next slide, please. So after we gained a better understanding of kind of the DMAs and how they grouped and their similarities, we were then able to build predictive models. And this predictive model kind of was initially used, well, I say predictive model, several predictive models using various algorithms to understand which one was going to best perform for this particular business problem. So we used a whole array of different statistical algorithms. We spoke with the stakeholders to understand kind of how the analysis was working, to make sure that they were able to take actionable and kind of actions off the back of those models. And some models are quite explainable with it really easy to take actions off, and some are much more complex and kind of more black box, which obviously doesn't make them that useful in terms of being able to take action. So after we found the best algorithm, we went on to the next slide, sorry. We went on to look at route optimization. So as Chris rightly mentioned, there's lots of different kind of ways in terms of kind of optimal search routes and the like that can be used. And this particular example kind of fits quite nicely with the traveling salesperson problem. And this is basically trying to find the shortest route to be able to visit every point on the plot kind of once and return back to base. So it's a really similar problem to how you would imagine a leakage technician would work. They leave home, they go out, they go to various locations in what we hope is an optimal route, and they return back home. So the image on the left shows how you would likely do it if you just went out and just looked. And the image on the right is if we optimize that route and kind of show people the order to go to these points. And the way that we've used this optimization, the route optimization, is by building in the risks. So out of the predictive model, we get a risk score for every pipe in the DMA. And then the route optimization basically tells you which pipes to go to and what order. So we start on the highest and the medium risk. So those are the ones we send you to first. And then obviously, if you still haven't found them, you start to work down that list towards the low risk. And then the final element of this, if we just go on to the next slide, is the user interface. This is the most important part of the project. It's the bit that kind of overlays everything that's been done. So it's providing the insight that we're providing back to the business in a way that they can understand. So it's provisioning the business with all of the data that they need, so that when a technician goes out and they find out what their route is, they have everything kind of within that application that would allow them to do this. So this is the last step of the process. It's the bit that we're on at the moment, is trying to make that so it's a fully usable interface. So that's very much a mock-up that you've got on the screen there. But we'll go through lots of testing with Chris's team, and we'll make sure that the deployment of this is not just kind of us pushing it over the wall at the Leakage team, but very much kind of teaching them, showing them how to use it, and getting as much feedback as we can to make sure it embeds. And I think that's everything. So thank you very much for listening. And if you've got any questions.
Thank you very much, Willow, and thank you, Chris. And we do have some questions along the side, but we also have some other questions I'll go through first. And I'd like to start off with Chris Smith and Carol White. At an earlier session this morning, I think it was Jeremy Heath who said that we're going through a very exciting time in the water sector, and particularly in the area of leak. You both have come from different sectors. So Carol, I think Chris, I believe you worked in the banking sector, and I think Carol, you worked in sports and in a state agency. So I'm curious, how did you into the water sector, and how open did you find us to new ways of working with data science?
Wow, that's an interesting question. Thank you. Yeah, so interesting that I joined Yorkshire Water on the graduate scheme. So I sort of didn't specifically join for a data related role, but sort of naturally found myself gravitating towards using data to approach business problems. And I initially started working in Leakage because of all the areas of operations, Leakage definitely seemed the most mature, the most sort of open to using data, the most the biggest opportunities in terms of using data, and that's where I sort of started and where I sort of gravitated towards. So it's what we're seeing now is, and it's sort of mirrored by the development of our team. So we started off as the asset analytics team, basically born out of the escalation we had in Leakage around sort of 2010 when we had the bad winter then, and sort of the team was set up to deliver benefit in that arena, and then the rest of the business saw what we were doing in Leakage and said, you know, can we have some of that as well? And that's So, and the team grew up around that. So yeah, I think Leakage is a lot more mature than a lot of different areas, and it's probably at the forefront of these more advanced techniques that you know, I'm sure have been discussed. So the applications of machine learning, Leakage is an absolutely ripe opportunity for that, and obviously the stuff that Willow and Chris shared is a great example of that being used in a practical way. So yeah, that's me.
Yeah, from my perspective, so I joined Yorkshire Water about 2.5 years ago, as you said, from a very varied background. So I have a PhD in marine biology, which is probably the closest link to Leakage of my work history, and moved into sports in a state agency. But my previous data roles were much less reactive, much more time and freedom to do things like hindsight analysis and predictive analysis. And then joining Yorkshire Water 2.5 years ago was a completely different setup, I won't lie, because there's that operational need day to day. You need to be delivering something for somebody to use now rather than tomorrow or in a week's time. it's a different pace. So I, like Chris, ended up working with Leakage initially, was where my first move into Yorkshire Water was, which probably softened the blow. As Chris said, Leakage is ripe for data analysis. But as some people at this conference will know, I've moved more into the customer experience world, as that has started to develop at Yorkshire Water as being ripe for machine learning and algorithms to be applied on customer data. So yeah, it's been eye-opening, and I'm still here, so it's obviously worthwhile.
And we're happy you are as well. The agile approach, I'm going to ask Chris and Willow about this. All of you have talked about this being a new approach to the water sector, to how we approach projects and so, which seems to be critical to the success and use of data science. How easy or difficult have you found that to use that approach in Welsh Water? Because I think we'll have the same challenges across all the sector, but you seem to have used it very effectively. But any challenges you'd like to pick out from that?
Yeah, there's definitely been challenges along the way. So obviously moving from waterfall to agile is quite a big kind of cultural change. I think for years and years in kind of software development and kind of that sort of field. And I think it fits really nicely for particularly for like data science projects. And I think that the reason it fits so nicely is because it enables that really frequent communication with stakeholders. And I think probably one of the biggest challenges is probably that change piece in reality, is that embedding the change into the business. And for often it's because people really understand data, they really know how to do their jobs. Like, you know, a lot of the leakage technicians know the DMAs like the back of their hand. So obviously kind of what we're trying to do is build almost download their brains and put it into a model to try and help other people that don't have it kind of on like know it like the back of their hands, so people that are new to the business and things like that. And I think that what the agile approach enables us to do is kind of keep downloading little nuggets and kind of feeding it into the model and building the model as we go. So rather than thinking really big, okay, well, we need this leakage model, we probably need 20 different data sets to feed into it, which in reality a waterfall approach probably would do. Instead, we go, okay, well, what handful of data sets do we have available to us that are fairly good quality, that we could easily link together, that we could start building a model on and see how well it performs, and let's keep building on it. So rather than every 4 weeks us basically taking a whole handful of data sets and pulling it all together, we just take 1 or 2 and we just go, okay, well, if we add this data set in, what impact does it have on the model? And then almost kind of decide on an end point, go, well, you know, we're performing at 90% accuracy, we're happy with that. Actually, there's no point in us trying to put more in. We're not going to get anything by trying to go up to 92%, so it's not worth the effort. So it really helps with that kind of stop point as well.
Yeah.
Great, and probably helps to bring the teams with you because they can see that progress pretty quickly as well.
I think that's,
okay, well, we have
a key part is like the collaboration between the two teams. You know, with an agile approach, you do really foster that collaborative working between the teams because there's so regular contact. I guess that, you know, as a leakage team, we sort of feel listened to along the way as well. So, you know, we're like feeding into the development. So the output really is in our gift. So that, you know, the more we put in along the way, the better the output as well.
The better the output. Absolutely. Thank you. Okay, I'm going to go for some of the questions along the side. Annam Gray. Hi, Chris, Willow. What benefits have you seen to date from your new approach?
So it is very new. So we haven't quantified any benefits yet. But what we kind of envisage is that where we would have used experienced or local resource to tackle a leak outbreak, we could use the most efficient resource. And I think that's really important with leakage because it can become very reactive at certain points of time in the year. So managing the resource effectively is key, you know, to making sure the normal leakage detection carries on as well as, you know, coping with the reactive breakout. And just recently we started using some resources outside of the leakage team to undertake some of this sort of reactive leakage investigation. And we think this tool alongside some of the technical kit from the manufacturers, allow us to use somebody who's relatively unskilled in leakage to find leaks quite quickly.
Very good. Alan Cunningham, thanks Chris Willow, very interesting. Are you able to talk about what data sources went into the leak location model and what was the quality of the data set?
Yeah, so yeah, really good question. Lots of different data sources. Probably too many for me to probably start listing now, because obviously the way that you work is you start to build in lots of different data, and you kind of build the model in a way that identifies which variables are have the most importance to the model, and so you may add some data into the model and then you may take it back out again, almost because it's not as useful as you initially thought. But data that we've kind of been using is around kind of the GIS data, kind of around lots of the pipe characteristic data sets, and a lot around like burst history and kind of job history, or so really anything that you can think of that relates to leakage. We probably looked at pressure data, kind of all sorts of things like that, and the quality of it. So this is a really valid question, because I like to say kind of that kind of old saying of kind of garbage in, garbage out. It very much is the case for these types of models. And I mentioned in my talk that data quality is really pivotal to everything. We can build a model that performs at 90%, but if the data quality is abysmal, it doesn't represent kind of what the real life is, then there wasn't much point in us really building it. So leakage data is actually a data set that is fairly high quality. Obviously, it's highly audited. It's kind of it's used a lot for regulation. But there's other data sets that we used that obviously aren't. That's not the case. So we worked really closely with the data governance team to kind of very much a collaboration in terms of identifying where there were maybe slight quality gaps in the data, so that they could work with the business area to try and improve that data quality as well. So I would say that the data quality varies data set to data set. Obviously, one of the first things as a data scientist that you do is you check the quality of your data, look whether there's anything you can do to improve the kind of the how full that data set is, whether you need to do any imputing of values or infilling. Yeah, as a whole for this project, the data was pretty high quality for a project, I would say.
Great. We have a question from David Victory. Carol, Chris, how do you measure the tangible benefits of analytical interventions, and what level of benefit is Yorkshire Water seeing from the use of these capabilities?
That's a really good question as well. Thank you. I think so probably it's a very difficult thing to do, obviously, but one of the things we're looking to do, particularly in relation to the smart network trial that's been alluded to a couple of times that we're undertaking at Yorkshire. So that involves basically installing a lot of new and different bits of telemetry in an area of Sheffield, along with smart metering data on both households and non-households. And that's all been sort of wrapped in an analytical platform. And obviously what that analytical platform is there to do is to enable operational staff to work with that data and sort of to act upon it. So one of the things that we should be able to do, and we're obviously quite in early stages at the moment, but we should be able to quantify what a 1 FTE of ALC resource delivers in a normal leakage area in the same sort of area, so another area of Sheffield, for example, versus what a 1 FTE of leakage resource is realizing in that trial area, because their activity is going to be directed, prioritized, promoted in a very different way. So we should be able to see a difference in the type of leaks they're finding, how quickly they're finding them, and obviously try and just to distill it down into a benefit per person value, basically. So that's the approach we're going to be taking in relation to that trial.
Okay, thank you. Karma Loveday has a question. How important is it to ask the right questions of the data in the first place? Questions that will yield data evidence to really support better decision making for the issue in focus. So who'd like to answer that one?
I think Willow covered it a little bit in her presentation, but super important to ask the right question, but it's also worth acknowledging that the first question that's asked isn't always the question you end up answering, and that's okay. So the agile way of working means that you can refine that question through time, and I think it's worth, you have the first conversation of, what do you want to do? What's your business use case? I want to be able to see this at this frequency, for example, might evolve over time into, I actually don't want to see that. I want to be able to do X. And you might have to refine the question through time. So I think in terms of ways of working between operations and the data science team, it needs to be that open communication that Willow's talked about, that allows back and forth refining of the questions, checking that the products that the data science team are delivering are actually adding actionable insight. They're not always going to, the question might not have been phrased or explored correctly.
I think it's
I think
acknowledging.
Go ahead, Willow.
In the specialisms as well. So, I think both ourselves and Yorkshire have alluded to the fact that leakage is a rich area for data, and probably somewhere we've been doing data science for some time. But it's probably acknowledging that we aren't data scientists really in leakage, so it's probably knowing your limitations and kind of asking each other the right questions as well.
Willow,
and I also think that I think it's also educating the business as well around kind of what is possible. And so it's kind of going back out to the business and almost saying what you can do and what you can't. And I know artificial intelligence is terminology that's thrown around, I think, everywhere, but there's actually a lot of things that aren't artificial intelligence. It's just coined artificial intelligence, and I think that sometimes it's going back to the business, and when they say, I want artificial intelligence to do X, actually it's not artificial intelligence you want to happen. It's just you want kind of a machine learning model to be able to predict something. It's that education piece very much. It's kind of going back, and rather than just going, no, it's not that, it's explaining actually what the solution could be and what it could look like.
Very good. Lewis Budworth has a question. Chris, I believe this is Chris Smith. You mentioned social media. Do you harvest sentiment outside your direct customer communication channels? And if so, how and what do you target, and how does it inform decision making?
Again, a great question. I think we're really sort of at the beginning of that sort of journey of understanding social media, understanding what we can get from it. Obviously, when you start looking at data outside of your direct channels, there's just a question around how do we make sure we're bringing stuff that is relevant to our operations, and we're bringing through that quality. We have explored that. One of the pieces we did right at the start of lockdown is we tried to look at social media comments around toilet paper shortages, of all things, and tried to sort of link that to where we might see issues on the waste network with blockages, so people resorting to alternatives. Which, apologies if you're just about to have your lunch, I know I am. So and obviously thankfully that's toilet paper shortage didn't quite materialize in the way it was anticipated, but examples of like that, it's quite sort of left field uses of that data. Again, I think we're really in a position now where we can bring that data through into a sort of a structured platform and start really exploring the potential of it.
Great, Chris. And we are running out of time, but I think I'll just ask one last from James Hargreave. Hi, Carol. Have you looked at using the emotion engine for staff and operations teams as well as for customers?
Yes, we have. And I'm mindful we've got some Yorkshire Water colleagues on the call who may not know this. Yes, we have started trialing it. So the model has been built with the customer, our external customer written feedback in mind. But what we're doing is trialing the model on other data sources. So in terms of external customers, we want to apply it to transcribed calls, which will be brilliant. But again, the model will need to be tweaked. But we have applied the current external model to our internal colleagues. So I'm sure, as most organisations have been doing through lockdown, is assessing how our colleagues feel at the moment, how are they finding lockdown, working from home, and so on. And we have used the model to help refine, 3,500 responses, a lot of text coming with it, and our kind of internal comms team are really struggling to work through that, to work out who are the colleagues out there that might need extra support. So we have applied it to that to kind of pull out the emotions of our colleagues that require an intervention, or we should at least be looking at. So we managed to break it down into the 6 areas of the business. So finance, waste, clean. I'm not going to go through all 6 because I can't remember them now off the top of my head, to see which area of the business was struggling most with different things. Worked really well. It's highlighted the need that maybe a tweaked model will be needed for different solutions like that. So obviously our external customers are more likely to be talking about how it's impacted, say, internal sewer flooding in their basement. Our internal colleagues are more likely to be talking about fatigue or frustration, for example. But yes, James, and it works well.
Thank you, Carol. And I'm going to be very naughty and I'm going to ask one last question because this was the first person to ask a question. So if we could do it again very quickly. Carol, Chris, excellent presentation. In order to improve your data science capabilities, did you do a recruitment drive to employ more data scientists, or did you upskill those already working for Yorkshire Water?
Hi, Michael.
Maybe.
We're already in, Michael and I are in touch via email, so brilliant question. It's been a mixture of the two. So Chris alluded to how he joined the business and worked his way into asset analytics and into data science. It was an organic growth, but when I joined the business 2.5 years ago was when we had our big recruitment drive. So I came in along with, I want to say, about 6 or 7 data scientists at that time. I'd say half our data scientists, maybe just less than half, are internal colleagues that have moved from elsewhere along the business or come along the journey with us. The other half are externally recruited from a huge range of backgrounds. Some are academics or were academics in psychology, now working on trunk main leakage. That step is possible, just to point that out. And then, as Chris and I have talked, our very different backgrounds to come in at our level. We recruit gradually now to either fill positions as people move on internally or externally with the business. But yeah, it's half and half. And I'd say that the great thing about bringing external people in is that new way of thinking can be great to bring in, but then they need to learn the domain knowledge. Your internal colleagues have got that domain knowledge. They know how it works and they fit straight in. But then there's that technical development that might be needed. So I think, Chris might disagree with me, I think it works quite well having that mixture of the two.
A mix of both.
Yeah, absolutely.
Great. But unfortunately, I'm going to have to draw a close now. Thank you very much, Chris Smith, Carol, Willow, and Chris Rees. We're now closing for a lunch break. Just to remind everybody, we have over an hour. And the next session will start again at 2 p.m. So please don't forget to visit the expo, just as you would if we had a physical conference. And again, please remember we have one-to-one networking in the networking session, and in the coffee shops we have several sessions as well. So for those of you who may want to continue with this session, or indeed with discussion that we had earlier on today on innovation, you can do so in those sessions. So again, please come back promptly 2 o'clock, and we'll start the operational and technology development support. Thank you all. Enjoy your break.